We're going to compute f prime of 4 if f of x is equal to the square root of x plus 5, and we have to use the definition of the derivative, not differentiation rules. I'm going to show you how to do that by using 3 different methods, and you decide whichever one is easier. They're all equally valid. First method, we're just going to compute the derivative. By definition, f prime of x is equal to the limit h approaches 0, f of x plus h minus f of x, and divide that by h. So let's compute each part first. F of x plus h is just the square root of x plus h plus 5. The next step is to take f of x plus h and subtract f of x, and that's equal to square root of x plus h plus 5 minus square root of x plus 5. Now what we want to do, we want to free up the h, so we're going to multiply this difference. So x square root of x plus h plus 5 minus square root of x plus 5. Let's multiply it and divide it by its conjugate, which is the square root of x plus h plus 5 plus square root of x plus 5. And of course divide by the very same thing so as to not change the problem. And this is equal to, the numerator is x plus h plus 5 minus x plus 5, so you can see that the x's and the 5's cancel, and in the denominator we have the conjugate square root of x plus h plus 5 plus square root of x plus 5. And so let's summarize this. The difference, f of x plus h minus f of x, is equal to h divided by the square root of x plus h plus 5 plus the square root of x plus 5. Now we'll take that difference, f of x plus h minus f of x, and we divide it by h, and that will have the effect of canceling this h here that I'm circling, and that will leave 1 divided by square root of x plus h plus 5 plus square root of x plus 5. And the final step is to find the derivative by taking the limit as h approaches 0 of f of x plus h minus f of x over h, which in this case is the limit h approaches 0, 1 divided by the square root of x plus h plus 5 plus the square root of x plus 5. There's only one h here that goes to 0, and that leaves us with 1 divided by 2 times the square root of x plus 5. So now we can answer the question originally posed. We wanted to find f prime of 4 if f of x is equal to square root of x plus 5. We just computed the derivative. The derivative was 1 divided by 2 times the square root of x plus 5. We're now going to plug in 4 for x in the derivative, and this is 1 divided by 2 times the square root of 9, or 1 over 6. So the answer is f prime of 4 is equal to 1 over 6. Now let's look at method number 2. Method number 2, we're still going to use the same definition of the derivative, that is f prime of x is equal to the limit as h approaches 0, f of x plus h minus f of x divided by h, but this time we're going to plug in 4 at the beginning rather than at the end. So f prime of 4 is equal to the limit as h approaches 0, f of 4 plus h minus f of 4 divided by h. So let's find f of 4 plus h. That's square root of 4 plus h plus 5, which is square root of 9 plus h. and f of 4 is equal to square root of 4 plus 5, which is square root of 9, and that's equal to 3. Okay, so now we can compute the value of f prime of 4. It is equal to the limit as h approaches 0. F of 4 plus h is the square root of 9 plus h, minus f of 4, that's 3, divided by h. Now to evaluate this limit, we plug in 0 for h, we get 0 over 0, so we'll use the conjugation method. We'll multiply by the conjugate of the numerator, 9 plus h plus 3, and divide by the very same thing, the square root of 9 plus h plus 3. So this gives us the limit as h approaches 0, 9 plus h minus 9, and this is divided by h times the square root of 9 plus h plus 3. You can see the 9's cancel. That leaves h in the numerator. This h now will cancel with the h in the denominator, and that leaves the limit as h approaches 0. 1 is left in the numerator. In the denominator we have square root of 9 plus h plus 3. As h goes to 0, we get square root of 9, which is 3 plus 3 in the denominator, and that's 1/6. The very same answer that we got when we used the definition of the derivative. Once we find the derivative, we plugged in 4 for x. The third method uses an alternative definition of the derivative, which of course is the same thing in the end. The third method uses the following. The derivative evaluated at value a is the limit as x approaches a of f of x minus f of a divided by x minus a. Sometimes this definition of the derivative is most useful. In our case, a is equal to 4, so the problem becomes finding f prime of 4 is evaluating the limit as x approaches 4 of f of x minus f of 4 divided by x minus 4. Now we already know from before, we plug in 4 for x into the function, we get square root of 9 or 3. So this is equal to the limit as x approaches 4. F of x is square root of x plus 5 minus f of 4, which is 3, divided by x minus 4. So now we want to evaluate this limit. When x goes to 4, the numerator becomes square root of 9 minus 3, which is 0, and the denominator goes to 0. So to evaluate this limit, again, we multiply by the conjugate of the numerator, square root of x plus 5 plus 3, and divide by square root of x plus 5 plus 3. That doesn't change the problem, it's just 1. And this yields the following limit as x approaches 4. The numerator becomes x plus 5 minus 9, and the denominator x minus 4 times square root of x plus 5 plus 3. Now x plus 5 minus 9 is x minus 4, so this is the limit. X approaches 4, x minus 4 in the numerator divided by same x minus 4 in the denominator times the square root of x plus 5 plus 3. So these cancel, and we're left with the limit as x approaches 4, 1 divided by square root of x plus 5 plus 3. So x approaches 4, the denominator becomes square root of 9, which is 3 plus 3. Denominator is 6, and the final answer is 1/6. So in all three cases, using all three methods, of course, we arrived at the same value of the derivative, which is 1/6. For